Yes, or are we going to have something else to do at lunch? All right. We talked last week about intersections and the distance from home to school. What did we find out at the very end?
No pattern.
Okay, no pattern. Good deal. There's no pattern. Now, there is a relation because for me, my point on that graph that we did was 1 mile and 1 intersection. Those two are related. Your points, whatever they were, are related. That's your distance to school and your mileage to school. Now, all of our points, when we put it on one graph, did not show a pattern. So we could not do what? Because we had no pattern. What did I say we couldn't do? Make a... No, we made a graph. We couldn't answer some of the questions because if I wanted to say, you live 7 miles from school, how many intersections are you going to go through? Could we do that? No, because there was no pattern. We could not make any predictions based on our graph or our data. It was all over the place. Well, today with what we're doing, it's called burning calories. We will be able to make a prediction, okay? And we already know what that is. Give me an example of how calories and workouts are related. Just what's the relationship?
The longer you work out, the more calories you burn.
Like when you work out, like your body burns.
Exactly. Needs energy. So the more you work out, the more calories you burn, correct? So we have a positive relationship. When one goes up, the other does what?
Goes down. Up.
Up. The more you work out, the more calories you burn. That's the only reason we work out. Yeah. So we're going to see that relationship in a table and in a graph today. But we already know what we're expecting. Let's look with me on the sheet that I handed you. And the writing above basically says what I just said, except for one thing. When you count calories, you're really counting kilocalories. Okay? We just don't call them that. We call it calorie with a big C. So that's the units. It's going to be like big C-A-L, but it's actually little c-a-l is really 1,000 calories. Okay? So our big C-A-L, just a little trivial piece. It's in here. You can see mathematically and by the science how a 1 calorie is defined, but just know that when we say I burned, okay, that Coke has 140 calories in it, it really has 140,000 calories in it. But it's not that we have to burn off 140,000 calories. We just shorten it so it's easier to deal with. Okay? You'll hear me say this a lot during the year, that mathematicians are basically lazy. So we try to find a shortcut to do everything, and that's what we're going to see a lot in the math. We're going to do things the long way, and then I'm going to show you, okay, here's how we really do it. Here's one way to do it. Here's how the fast way to do it. Okay, so we're just going to cut off those zeros. We know they're there. You never even knew they were there before today. It's not going to change the way you think about calories at all, but just know that there's 3 more zeros out there on everything. With that said, you can read about it up here if you want to. Let's look at the table. And I found some surprises here. Basketball burns 6.9 calories per minute. Football burns 6.6 calories per minute. I would have thought football burned more calories.
You don't run.
That's what people have been telling me all day, that it's harder to go back and forth up and down that field than it is, I mean, up and down that court than it is the...
Blame the
Because you keep on looking at basketball, you don't go
Yeah.
How would you say card playing you lose them? Yeah.
Someone did some research and they've given us these completely accurate numbers. These are roundabouts. Okay. Yeah, you're dealing those cards out. You're thinking about your next move. The more you think, the more calories your brain's burning. I mean, seriously. Okay, I'm dead serious.
You burn calories in math?
You burn a lot of calories in math.
I do.
Mathletics. Okay, so here is each activity, and here is an estimate of the calories they burn per minute. painting.
Football barely burns more calories than walking. Oh, yes. That doesn't make sense. Do you understand?
Yeah.
Walking burns more calories than football.
No, it doesn't. Football's 6.6. Yeah, but it's 33% more.
2 more, and then you got 50.
Yeah. Almost 3 more. They should have swimming. Swimming will probably be bigger than all of them.
So I can walk twice in one day and get more calories burned than
I don't know. Depends on what kind of dancing you're doing, too. If this is Zumba dancing, you're probably burning more than basketball.
Yeah.
But anyway, this is what we're going to work with. This is what we're going to work with. Okay. Shh. Okay, give me your attention. Now, do you remember back in 8th grade using proportions? Like this is proportional to that, and it worked with fractions and all that kind of thing? Okay. I know you had at least a packet or 2 on that, because it's on the list. We're going to practice that today, and I'm going to show you how you were even doing algebra back then. Okay? Now, let's take, it says use a proportion to calculate the number of minutes. So what are we looking for? Repeat it with me, number of minutes. If we're looking for something, what are we going to assign to that something? A variable, thank you. And what's the most commonly assigned variable to start with? X. Let's call that X. So we're going to be looking for X. It says use a proportion to calculate the number of minutes it would take to burn off 50 kilocalories while playing basketball. Okay, so we're going to take this activity right up here. It burns 6.9 calories per minute. Do you know what per means in math? Think about it.
Every.
It means some operation. It's either plus, minus,
Plus.
division, subtraction. Okay. Okay. It's division. Okay. Think about miles per gallon. This is really not part of what we're doing, but miles per gallon. You're going to divide miles by gallons. How about miles per hour for speed? Okay. This is going to be calories per minute. All right, we have one relationship, and that is that 6.9 calories are burned each minute you play basketball. So I'm going to say 6.9 calories per 1 minute. Okay? Now, I'm not going to write these units out here right now. Just know that we're doing calories per minute. Now, if I'm going to do a proportion, what does the other side have to look like as well? What has to be on top? Calories again, because it has to match this one. So we're looking for burning how many calories? 50. So we'll put our 50 on top, and then we're looking for how many minutes that takes. So our X goes on the bottom. Now, do you remember what to do when you have a proportion? Cross multiply. Thank you. So this is going to be 6.9 X. See, I'm not even putting a time sign or anything. I'm just putting them beside each other. Equals 50. Can I just say that? Do I have to say 50 times 1? Okay, we're all, there we go. Because 50 times 1 is what? 50. All right, so now I have an expression or an equation that says 6.9x equals 50. That's algebra, folks. Y'all did it last year, didn't even know it. How do I solve for that x? I just want the x. Okay. Divide by 6.9. And what can I do? Why did I divide by 6.9?
Get rid of X.
You're looking for the value of 1x. Thank you, Isaac. And what is 6.9 divided by 6.9? 1. Anything over itself is 1. So that allows me to say, okay, that's 1. That's my 1x. But if I did it over here, what do I have to do over here? Okay, 6.9. So x, the number of minutes, is going to equal 50 minutes, or excuse me, 50 calories divided by 6.9. So what is that? Let me just say, welcome to high school. Go get a calculator. Yeah. Now, right now, I don't have enough. You may use calculators on the EOC test. In fact, you will want to use a calculator on the EOC test because we are going beyond addition, subtraction, multiplication, and division. We're going into functions. These things will graph for you. These things will solve equations for you if you know what to do. So a lot of Algebra 1 is teaching you how to use the tools that are out there. Okay? Now, come Monday or maybe later this week, you will be assigned to a calculator, which means you will be responsible for the care of that calculator, and I'll be checking to make sure that they are well cared for. So don't get any ideas about abusing them. They're going to help you, so don't be mean to them. Okay? All right. So we had 50 and we divided it by 6.9.
7.25.
I'm just dividing 50 by 6.9 because that's what we decided x would be. And we're going to round that to 7.25. Okay? So what is 7.25? What is that?
7 and 1/4.
So that's 7 1/4 minutes it takes to burn 50 calories playing basketball. Basketball.
Coach out just wrote something on the board and we had to follow it.
Now this is simple proportion. And once you, that's why we're going to interact a lot with our math, because it's just life. I mean, we're going to work out situations and problems like this all through the course. All right. Bye-bye.
Where's he going?
He's got a migraine. All right. Turn with me to the next page. Here's what we're going to do. Each table, I'm going to assign a different activity off of our list. Okay, if you're a football player and you get dancing, don't complain. It's just a number we're going to calculate, all right? You're going to work with your table group, whether it's 2 or 3, and you're going to complete this chart and then go ahead and complete the graph that goes with it based on what we just did. Now, when you get your activity, write it out to the side, like if you get basketball or whatever it is. Now, I would go ahead and write the number here, like it was 6.9. That's how many calories it burns per minute. How would you find, if you're trying to find how long it takes to burn 100 calories, and it takes 6.9 calories for every minute, how are you going to find the time?
100 divided by 6.9.
Exactly. 100 divided by 6.9. If you got walking, it's 4. 100 divided by 4 is, okay, you're going to do that calculation here. Then you're going to graph it here. Now, something I want you to be careful of. Look back at the board from last week. What goes on the left?
Output, reaction, and effect.
Okay. If you're looking at it, what's on the left? X. That's your input. It's all right. X goes on the left. Now, if that had been a flower over that column, we'll just put the flower, right? Now, what is in that column? What's the first word in there? Up there. Input. Your input always goes here. I'm going to call that X this time because that's what we're working with. I'm going to call that Y. But this, remember, is your input, and this is your output. Okay, so do those calculations, and then set up your axes. Which one is going to be your x-axis?
The one going horizontal.
This one?
Very bottom.
Yes. I'm going to assign you one. I know.
I've already done it. We're going to be playing the piano. It only has 2
Okay,
calories.
do that.
We can't.
Go ahead, you do playing the piano, yes.
It's 2 calories. Please.